cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
Imagine a planet so dark it absorbs more light than a lump of coal. A world adrift in an endless, starless night, a phantom sphere practically invisible to the human eye. This isn't a scene from a sci-fi blockbuster. This is a real place. Welcome to TRES-2b, the darkest exoplanet ever discovered. Out there, orbiting a star about 750 light-years from us, is a celestial mystery. When astronomers first pointed their telescopes toward the TARES-2 system, they were using a technique called the transit method. This means they were waiting for the planet to pass in front of its star, causing a slight dip in the star's brightness. This method is standard for finding exoplanets, but what they found with TARES-2b was anything but standard. They expected to measure the light reflecting off the planet's atmosphere, just like we see with planets in our own solar system. Venus, for example, is incredibly bright because its thick clouds reflect most of the sunlight that hits it. Even darker planets reflect a noticeable amount. But TARES-2b was different. The data came back, and it was baffling. The planet was reflecting less than 1% of the starlight that fell upon it. To put that into perspective, that makes it darker than fresh black acrylic paint, darker than asphalt. It's a void, a shadow in space. How could a planet be so incredibly dark? The discovery sent ripples through the astronomical community, challenging the very models they use to understand planetary atmospheres. So what is this phantom planet actually like? TARES-2b is a gas giant, a hot Jupiter as they're known, roughly the same size as our own Jupiter. But that's where the similarities end. It orbits perilously close to its parent star, completing a full year in just 2.5 Earth days. This close proximity roasts the planet, pushing its atmospheric temperature to over 1,000 degrees Celsius, or about 1,800 degrees Fahrenheit. It's hot enough to melt lead. This intense heat plays a crucial role in its darkness. The planet's atmosphere is a toxic, scorching brew of chemicals that are exceptionally good at absorbing light. Scientists have detected vaporized sodium and potassium, along with titanium oxide gas, all swirling in its upper layers. Instead of forming reflective clouds like water does on Earth, these chemicals remain in a gaseous state, acting like a dark, light-trapping fog. This leads us to the core question. Why is it so profoundly dark? Think about the planets we know. Earth has white reflective clouds and blue oceans. Jupiter has its famous swirling bands of ammonia clouds. These features all bounce sunlight back into space, giving the planets their characteristic appearance. TARES-2b seems to lack these reflective cloud layers entirely. Its extreme heat prevents light-reflecting compounds from condensing. So, instead of having a bright, cloudy shield, its atmosphere behaves like a cosmic sponge. Light from its star enters the atmosphere, gets absorbed by the exotic chemical soup, and is converted into heat. Very, very little of it ever escapes. The planet glows, not with reflected light, but with a faint, deep red heat, like a piece of charcoal on a barbecue. It's a world that literally eats light. Let's try a thought experiment. Imagine you could somehow float in the upper atmosphere of TARES-2b. Of course, the heat and pressure would be instantly lethal, but let's just imagine. You'd look up and see its star, a massive glaring sun hanging in the sky. But when you look down, toward the planet beneath your feet, you'd see nothing. Just an endless, featureless, pitch-black abyss. The darkness would be so absolute, so disorienting, it would feel like staring into the void itself. This extreme environment is pushing the boundaries of what we thought was possible for a planet's atmosphere. It's a natural laboratory for studying how matter and light interact under the most intense conditions imaginable. For scientists, a puzzle like TARES-2b is an incredible opportunity. It's a cosmic outlier that forces us to rethink our theories. Astronomers are eager to point future, more powerful telescopes, like the James Webb Space Telescope, toward this dark world. By analyzing the faint light that does manage to filter through its atmosphere, they hope to get a more detailed chemical fingerprint. They're searching for other unknown light-absorbing compounds that could be contributing to its extreme darkness. Could there be exotic materials or chemical processes at play that we've never encountered before? Answering this question could unlock new insights into the formation and evolution of gas giants across the galaxy, especially those in extreme star-hugging orbits. Now for the question that always captures our imagination: could there be life? Given the scorching temperatures and hostile chemical environment, life as we know it is completely out of the question. A carbon-based organism would be incinerated in an instant. But the universe is vast and full of surprises. Could there be some exotic form of life, perhaps silicon-based, that doesn't rely on liquid water or sunlight? Could something evolve to thrive on the planet's immense heat energy? It's pure speculation, of course, but planets like TRES-2b are a humbling reminder that our definition of habitable might be far too narrow. The cosmos is weirder and more wonderful than we can possibly imagine, and the rules of life might be different out there. In the end, TRES-2b remains a ghost planet, a silent, burning, and nearly invisible giant lurking in the cosmic dark. It's a world defined by its absence of light, a place that challenges our senses and our science. Yet, yes, in these darkest corners of the cosmos that science often finds its brightest sparks of inspiration. It proves that even when we look out into the void, there are still wonders waiting to be found. Somewhere out there, countless other strange and mysterious worlds are orbiting distant stars, each with its own story to tell. And we're only just beginning to listen. Thanks so much for joining me on this journey to the darkest planet we know. If you love exploring the mysteries of the universe, don't forget to hit that subscribe button and ring the bell so you won't miss our next cosmic adventure. See you next time.